Okay, first thing we need to start with is mole conversions. You need to be comfortable going from moles to grams, grams to moles, moles to how many atoms or molecules, how many atoms or molecules to moles, as well as moles to liters and liters to moles. Okay, how do you set those up? All right, we have 3 different conversions. I'm going to show you both ways. Okay, here's your number of things, here's your grams, and here's your liters. Okay, so if I give you how many atoms are in 2 moles of neon? Okay, how many atoms, question mark atoms, are in 2 moles of neon? That's how you set it up. That's right from the question. Okay, what comes next is your conversion factor. Okay, your conversion factor. I know that moles have to be on the bottom, and it's going to be 1 mole for right now for all of these, because moles are on top, and I want them to cancel out. So get rid of moles. Okay, I know 1 mole is how many atoms. I go over here and look at what I'm looking for. I know that 1 mole is 6.02 times 10 to the 23rd atoms. I multiply that, and I should get 1.2 times 10 to the 24th atoms. Okay? I can also go the other way. Okay? I can ask how many moles are in 1.2 times 10 to the 24th atoms. So how many moles are in 1.2 times 10 to the 24th atoms? Okay? How many, I'm trying to go to moles, so I know that I want to end up with moles on top. How many atoms are in 1 mole? Well, anything. 6.02 times 10 to the 23rd things are in 1 mole, just like 12 are in a dozen. Okay? My atoms, I'll write them down. My atoms cancel, and I'm left with moles on top. So 1.2 times 10 to the 24th divided by 6.02 times 10 to the 23rd should give me 2. Okay? If you are an airport dymo person, okay, and you don't like using the factor label method, here's the other way you can do it. I'm going to draw this, all right? We have moles in the center because that is the airport. That is the central place to convert. Here's the number of things. Here's my grams, and here's my liters. I'm up here. My conversion factor from number of things, number of atoms or molecules is 6.02 times 10 to the 23rd. If I'm going in, divide in, multiply out. Okay, if I'm going from 1.2 times 10 to the 24th into how many moles that is, I'm going to divide in by the number that's on the line, 6.02 times 10 to the 23rd. If I'm going from 2 moles out to how many atoms that is, I multiply to get out of the airport. What do I multiply by? 6.02 times 10 to the 23rd. Okay? Let's talk about grams. If I'm looking for how many grams are in 2 moles of carbon dioxide, this is the case where it matters what it is. It matters that it's CO2. I know that 1 mole goes on the bottom to cancel out moles. So moles go away. And I'm looking for grams over here, so I need to put grams on top. How many grams are in a mole of carbon dioxide? Well, carbon dioxide, you need to get its molar mass from your periodic table. Carbon weighs 12 and oxygen weighs 16. So you add up the parts that make up CO2. 12 for carbon, and then I have 2 oxygens, so 2 times 16. That gives me 44 grams per mole. And that's what I put here. Okay, the 44 goes up here. If it were neon, it would be 20. If it were fluorine, it would be 19. If it were carbon, not carbon dioxide, but carbon, it would be 12. So that number, this number right here, is going to change depending on what that is. Okay? In this case, I get that it equals a nice 88 grams is 2 moles of carbon dioxide. If I'm going moles to grams, I'm saying how many moles are in 88 carbon dioxide. I already know that carbon dioxide weighs 44 grams, and I put the grams on the bottom now because I want grams to cancel. So grams on the top, grams on the bottom, those go away, and I know that's 1 mole. So when I divide that out, I get that this is 2 moles. So let's go back to our airport. When I'm going from grams into moles, so I'm going from grams into moles, I'm going to divide in by the molar mass. This is where you get it from your periodic table. Okay? If I'm going from moles out to grams, I'm going to multiply by the molar mass. And that's essentially what we just did on the other sheet, on the other page. Finally, we're going to talk liters. Liters are only for gases. So this is only gases. How many liters is 2 moles of carbon dioxide? The magical number you need to know is that 1 mole is 22.4 liters. Okay? Moles go away, moles cancel, and I'm left with 44.8 liters. Does not matter what it is, this 22.4 is the same for all gases at STP, or standard temperature and pressure. If I'm going the other way, okay, 2 moles, how many moles is 44.8 liters of carbon dioxide gas, okay? Liters are on top, so I'm going to put liters on the bottom, and I know it's that 22.4 again, okay? Liters go away, and I have 1 mole left on top, and my answer is 2 moles again. So now let's update our airport. Here's liters. What's my conversion factor? How do I get in and out of the airport? Using 22.4. Okay? If I know that I have 44.8 liters and I'm going into the airport, I'm going to divide in to get to liters, divide 44.8 by what's on the line, 22.4, and multiply 2 moles by 22.4 to get out. Okay? Last thing you need to know about liters is Avogadro's hypothesis. What that is that a gas at the same temperature, pressure, and volume have the same number of molecules. Okay? A gas at the same temperature, pressure, and volume have the same number of molecules. So if I have 2 liters of carbon dioxide at STP, okay, that has the same number of molecules as 2 liters of any other gas at STP. Okay? So if your volumes are the same, the temperature and the pressure are the same, your number of particles are the same. Okay? So for the test, you really just kind of want to match the volumes and match the conditions. If they're not at STP, match their temperatures and pressures. If all those 3 things are the same, the number of particles are the same as well. Okay? All right. Before we get to percent composition, I want to talk one more thing, like moles of atoms. So if I have NH4Cl, for example, that's ammonium chloride. If I have 1 mole of it, I have 1 mole of NH4Cl. Well, how many moles of nitrogen atoms do I have? I have 1 mole of nitrogen atoms. How many moles of chlorine atoms do I have? I have 1 mole of chlorine atoms. But how many moles of hydrogen atoms do I have? Because of that subscript 4, I have 4 moles of hydrogen atoms. I have 6 moles of atoms altogether in 1 molecule of NH4Cl. Okay? That is a tricky concept. And if you're asked a question on this, think about those smiley faces that I drew. If I have a dozen smiley faces, I have a dozen mouths, a dozen faces, and 2 dozen eyes. Okay? So if I have 1 dozen NH4s, I have a dozen N's, 4 dozen H's, and 1 dozen Cl's. Okay? That's kind of how that works. Don't make that one harder than it needs to be. All right. Percent composition I'm going to do nice and quick because it should be pretty easy. The formula is on the back of your reference table. The formula is the part over the whole times 100, and that equals your percent composition. So the part is the mass, the molar mass, of the element that you're asked about times how many, and I'll show you what that means, divided by the total molar mass times 100 to get a percent, okay? So if I'm asked about CO2, we've used that one before. If I'm asked about CO2, I want to know the percent composition of oxygen in CO2, okay, of oxygen in CO2. The molar mass of oxygen is 16, but I have two of them, so I need to make sure that I account for all of the oxygens in that CO2, divided by 44 times 100. And that is how you would calculate your percent composition of oxygen in CO2. If you were going to figure out the percent composition of carbon, there's only one carbon and it weighs 12, okay? I'm going to get rid of that equal sign because it's not equal, I guess. Out of the total molar mass of 44 grams. I'm using carbon dioxide because we already calculated the molar mass on a few previous slides, so I just want to make sure that you are, that's where that 44 comes from. Carbon weighs 12, oxygen weighs 16, and there's two of them, so that equals 44, right from your periodic table, okay? Last but not least is our empirical and molecular formulas. If you're given something like C8H18, don't think so hard. If you're being asked about what is the empirical formula, all you got to do is reduce it, okay? They're both divisible by 2, and I would get C2. Nope, that's not right. C4. 8 divided by 2 is 4. C4H9. Just double check that you can't reduce that any further, and that's how you go from a molecular formula to an empirical formula. Remember that a molecular formula is just a multiple, okay? So if for example, I had, let's use our favorite CO2 again, okay, and I said that this is my empirical formula. The molecular formula weighs 88 grams per mole. So what is it? Okay. First thing that you need to do is figure out what is the mass of your empirical formula. Okay. In this case, it's from your periodic table, 12 plus 16, but there's two of them. It weighs 44. Okay. How many times do you multiply 44 to get to 88? In this case, it should be pretty clear that it's 2, but how do you do that? Take the bigger number, divide it by the smaller number, and you get a factor of 2. So you take that 2 and you multiply it by your empirical formula to get your molecular formula. In this case, it would be C2O4. Okay? Now, to find an empirical formula, if I don't give you the molecular formula, you need to figure it out the long way, okay? So I'll use an example that we've used before. Find it. Here's an example that we've used before. I'll walk you through the 3 steps. If I have 11.2 grams of iron and 21.3 grams of chlorine, okay, I need to figure out what's the empirical formula. If you're given percents, you assume a 100-gram sample and just change the percent signs into grams, okay? So if it was, this could be 11, I wouldn't work that way, but I'm going to figure out how many moles of iron and how many moles of chlorine I have first. So take the amounts that you're given. I'm going into moles, so I divide by the molar mass of each, okay? Molar mass of iron is 56 grams. Molar mass of chlorine is 35.5 or 36 grams. Or I think 35 is what it rounds to. Divide them both by their molar mass. So this is the molar mass. Divide both grams, or if you have percentages, divide both percentages by the molar mass of that element. Okay. In this case, I get 0.2 for iron and 0.6 for chlorine. I would suggest carrying some more decimal places here. In this case, it works out pretty well, pretty even. Okay, but if you carry through 2 or 3 decimal places in this at this step, it'll make your numbers work out a little bit nicer. Okay. The next step is to divide both of these answers by the one that's smaller. 0.2 is smaller than 0.6, so I divide them both by 0.2. This is where we get our smallest whole number ratio. Okay, so my number for iron is 1 and my number for chlorine is 3. What that basically says is that for every 1 iron, every 1 mole of iron, I have 3 moles of chlorine. Remember that those subscripts are moles, they're not grams. So I have Fe1Cl3, and that's my empirical formula. If you were given a molecular mass, you could then go on to find the molecular formula, what the multiple is. Now, if this worked out so that this was not 3, but say it was 2.5. Whenever you have 0.5, you cannot round it, okay? Do not round your 0.5, okay? What you need to do is you need to multiply them both by a number to make it a nice whole number. In this case, if I multiply it by 2, and I think that's as hard as it will get, you'll just multiply by 2, multiply this one by 2 and this one by 2 to keep the ratio the same. You'll end up with, if this worked out to be those numbers, it would be Fe2Cl5. Check those numbers. Is that still empirical? In this case, yes, it is. Okay, but this one is not a case like that. But that's about as hard as they get. Okay. That's pretty much everything that you need to know for this test. I would suggest doing a bunch of practice of mole conversions. If you picked up the 2 review sheets in class, remember that the second page of the packet, where there's all the equations, where there's arrows, etc., we did not learn that yet. So anything that's asking you about using an equation, ignore it. We haven't learned it. We won't learn that till January or so. So don't let that freak you out, okay? All you got to be able to do is what I just showed you on this video. Good luck.